And today we'll speak about stacking, boosting, and online learning in distributed mode with Apache Ignite. And before I start, let me put a couple of words about myself. Is it working? Of course not. Okay, I'll do this way. Actually, I started this project, machine learning module for Apache Ignite and GridGain 2 years ago. And nowadays, I'm leading the development of machine learning and deep learning module in GridGain and Apache Ignite, and also currently I'm Apache Ignite committer. So I know all this product from the beginning, at least this machine learning part. And today, I'll provide the brief overview of distributed machine learning and deep learning and the difference between classical approach in the single node environment and distributed environment, and which problem do we have when we transfer from this classical approach where we have our usual data scientist workplace with his regular instruments. After that, I will show how we can perform data preprocessing and model training in distributed mode with Apache Ignite and GridGain. I will show how we could build machine learning pipelines, and I will show how we could use boosting, stacking, bagging, and online learning with Apache Ignite. And also, I will show some cool extra features, including really new one for Apache Ignite and GridGain. So, shall we start with distributed machine learning? And why do we need distributed machine learning itself? If you listen in the previous keynotes, the speaker mentioned that they have billions of data points. And usually we try to subsample it and analyze this subsample. But it's really usual situation where you cannot do this split. You cannot extract representative subsample, because if you're able to extract it, basically it's equal that you situation where you don't need the whole your data, and you're able to train a model which is mostly ready for inference and for prediction, using only this subsample data. So we need distributed machine learning not when we have lots of data, petabytes of data, but we have petabytes of data and we need all this data for performing machine learning. And that's the reason why we cannot use our standard approach like scikit-learn, for instance. If we try to build the model that uses petabytes of data with scikit-learn, more or less it's impossible. But what should we do in that case? In that case, Apache Spark could help us. And I think that you're all familiar with it. Am I right? Okay, I see that all of you are familiar with Apache Spark. So Apache Spark is a really good tool. It's have lots of classical machine learning algorithms. All of these algorithms are distributed by the nature, and it have support of different data sources and things. So we have read our data from really different storages. Also, using Apache Spark, it's really easy to build a pipeline that we can use in production system. And we're able to evaluate our models using Apache Spark and perform hyperparameter tuning with that. And if we want to stay in a Java landscape and not to try to other instruments, now we have Apache Ignite as distributed machine learning and deep learning platform. And using Apache Ignite, we can perform mostly the same operations that we're able to do with Apache Spark. And today I want to show how we could do this. And I want to ask you if you're familiar with Apache Ignite or GridGain. No? Nobody familiar with Apache Ignite?
Yes.
But not all of you, so I'll put a couple of words about it. So Apache Ignite, it's a distributed memory computing platform. It's basically open source product and a GridGain solution based on Apache Ignite. And all features that I mentioned today, that all provided by Apache Ignite, and you also can use all of those features with GridGain, from the community edition till some more complex editions. And Apache Ignite, as I mentioned, is a distributed computing platform, and from this platform we basically need the next features. It's a distributed caches which provide key value distributed storage, which support data collocation, so we're able to deliver computation to our data and not move our data to computation devices. So we could save lots of time for ETL. And also we have a SQL engine. And today I will introduce our machine learning capabilities that we have. So, unlike Spark, we don't use RDDs internally. We have our own dataset representation. It's called partition-based dataset. And in Apache Ignite, we store our data in partition-based distributed caches. So, if we want to perform machine learning training over this data, we will create a partition-based distributed dataset. And this dataset consists of three parts. The first one is a learned environment. It's some stateless instruction that show how we will perform our training. The logging info level, parallel strategies, etc. And the context. The context contains intermediate calculations on each iteration of algorithm, because lots of machine learning algorithms are iterative, working in iterative way. And using these two parts, learned environment and context, we're able to create dataset data that are suitable for machine learning tasks, for preprocessing, for training, for inference. And using this approach, we provide the same guarantees for fault tolerance as we have for all our computational tasks in Apache Ignite. That means if our topology of our cluster will change during model training or data preprocessing, we will save all our data and we're able to perform training from the previous step. We don't lose any intermediate computation. So, let's take a look on the data preprocessing. Why do we need this step? Because data preprocessing can reduce computational costs of all machine learning algorithms. If you normalize your data, you will reduce the noise level inside them. If you scale your data, you will increase efficiency of gradient descent based method. If you will use encoder, you will encoding technique, you will able to work with categorical features and with string features and some more complicated entities. So, let's take a look on the short example of data preprocessing in Apache Ignite. And here you see on the first line, you can see example of performing data imputing. This preprocessor will fill the missing gaps in our data. For example, if our data if we register our people, for example, and use this information, all persons set their ages, for instance, and we can fill these missing values for using some strategies. The next one is a scaler, which will scale our data, and as I mentioned, it will reduce our computation costs. And the last one is a normalized trainer. And as you can see, we can build the chain of these data preprocessors, and we were able to apply them one by one to all our data set. And the last part is model training and model evaluation. I will explain this later on the next slide, on the next section. And if we have data that already preprocessing and ready for training, we should train our models. And in Apache Ignite, we have a bunch of algorithms for that purpose. For instance, we have lots of classificational algorithms like logistic regression, support vector machine, KNN, ANN, tree-based algorithms, naive bias, and other. We need this group of methods when we want to classify our data. For instance, if we try to analyze transaction flow, we use these approaches for finding fraud transaction. The next group of algorithms, it's regression algorithms. And in this group, we have a regression based on KNN method. It's linear regression, could be LSQR method or method that based on gradient descent. It also tree-based algorithms. And we need this group, this technique, if we want to predict some values. For example, it's one of the most popular example in the Coursera courses. We can use this method for house pricing prediction. If we sell in our price, or if we sell in our houses, or we sell in cars, or we sell in anything else, we could use these techniques for price prediction. Also, we have clusterization algorithms that are basically unsupervised learning that we need to analyze our raw data and try to split some groups inside the data, and we don't know the number of these groups, their features, why these groups split in that way and not in other way. In that case, we use unsupervised learning. And here we have k-means algorithms and Gaussian mixture model algorithms. And last but not least, we have our own implementation of neural network algorithms. Basically now it's a multi-layer perceptron, it's a basic neural network architecture, and for more advanced neural network architecture, we recommend using our TensorFlow integration, and I'll show more, I'll talk more about it later. As in the previous section, let's take a look how we can use all these features. As you can see, our API is really simple. All that we need is 5 lines. I will show it. The first one is obtain data from some file. Here, in that example, we use Titanic dataset. It's really some toy dataset that we use in our tutorials, in our examples. And when we have a cache with our data, we declare vectorizer. This entity helps us create labeled vectors, which show which features we want to use in our raw data, for which columns we want to use in our raw data as features, and which column we want to use as labels for supervised learning. And as you can see, it's really simple API. We can use indices, or we can use names if we deal with binary objects. The next line is just a declaration of algorithm that we want to use. Here, for example, we have a classifier based on decision tree algorithms. And after that, we just call one method. in our trainer, and we receive our model that are ready for working in production system. But if we want to decide if this model good enough or not, we have evaluators that provide several metrics that we could use for decide if this model good enough for us or not. And here you can see the accuracy metric. And we can check it and decide if accuracy good enough for us or not. So, as I mentioned before, the API is really simple. All that we need is just these 4 lines. The first line is just cache filling. We shouldn't look at it at all. So, and actually, it was our main purpose: keep API and keep this keep this instrument as simple as it could be, because we want to provide ability working with machine learning not only to data scientists, but to simple average Java engineer too. So let's take a look on the pipeline building. As I mentioned, it's really, in Apache Spark, it's really easy to build the pipeline, but why do we need them? Basically, we need these machine learning pipelines for building a solution that are ready for using in production when we have all our steps, when we have our preprocessing steps, where we have our model training steps, and possible some additional model tuning steps. And only all this box ready for working in a production application. So, as you can see, we have the next 3 steps: our preprocessing step, our training step, and our evaluation step. And we provide API for all those steps. And let's take a look on API of building machine learning pipeline itself. And it's really straightforward. Just as in previous step, we feel we have our cache with data. After that, we declare our vectorizer, how we want to work with our data, which columns we want to use as features, and what column we want to use as label. And after this, we just add all steps in this pipeline. And we start with our vectorizer. After that, we just add all our preprocessing steps. In this example, we have 4 preprocessing steps. And just add our model training as the last step. And after we will fit this pipeline, after we evaluate it, we are ready to use this pipeline as one model, which will accumulate all the steps in our system. So this model will be ready for working with our raw and pre-processing data. And all steps before we able to do with Apache Spark. But what can we do if Spark will not enough for us? And the main topic of my presentation is how we can work with boosting, stacking, bagging, and other model assemblies, and with online learning with Apache Ignite. So, and as I already mentioned, Apache Spark for now doesn't provide support of model assemblies algorithms, but Apache Ignite have this support. And here you can see the example how we can transform our classifier, yes, our classifier based on logistic regression to bagged regression. And as you can see, it's still the simple API. We just declare our transformer and set some information how we want to work with this transformer. For example, we pass the ensemble size, how many models we want to train similarity, and which strategy we want to use during this training. So the API is simple. Here there's only example for bagging, but we also have support of stacking and boosting. And also we have support of online learning. And unfortunately Apache Spark don't have it at all. So let's take a look on our API again. And here you can see the example how we could update our trained model, which is already trained on the first portion of data. And this API is really simple too. We really want to keep this pattern that for any additional action, all that you need is just one liner. We don't want to push you to write kilometers of code lines to configure it. It all should work out of the box. So as you can see on this example, it's working really on the same way like you just perform your simple model training. And you can use this API for building applications which have online learning capabilities. And also, other Spark limit that I mentioned, it's additional overhead that we have for ETL process, because if we want to build our labeled vectors, we should move our data to Parquet and build our labeled vectors only after that. And also, we have Apache Spark don't have native integration with deep learning libraries like TensorFlow. And Apache Ignite have this native integration, and we provide the next option. You can use Apache Ignite or GridGain as a distributed data source for TensorFlow. In that case, you will be able to read the data from Apache Ignite cluster using standard TensorFlow API. And you can see example how exactly we can read our data from a TensorFlow cluster. And basically, it's just one additional import that says that we should use Apache Ignite TensorFlow data set, because we perform some patches in TensorFlow and add native support for Apache Ignite in TensorFlow. So if you want to migrate from your previous approach to this one, all that you need is just change a couple of lines in all your TensorFlow tasks. Also, we support model storage API for TensorFlow via IGFS, but it's some kind of, this API is deprecated, and for all new releases since that moment, we will have other API that don't use our IGFS. We will use our own implementation of distributed model storage. And this distributed model storage, like the IGFS plugin, also will allow us to work with all TensorFlow instruments like TensorBoard. So we could see all statistics for our deep learning models. And the last option, it's really advanced one. We provide the ability of building distributed TensorFlow clusters on top of Apache Ignite. And in that case, we have a cluster management system for TensorFlow that will deploy TensorFlow clusters near the Apache Ignite clusters on the same node where we store our data for distributed training. So on each node where we have our data, we will deploy a TensorFlow instance. We'll build a distributed computation graph, and we will maintain this cluster during the whole training process. So if something goes wrong, if our cluster change topology, not only Apache Ignite cluster, but even TensorFlow cluster, or if something goes wrong with network, we will restore cluster, we will save all our intermediate calculations, because if we speak about deep learning models, sometimes train of one models, it could take a days. So intermediate calculations, it's really valuable resource in that case. And we provide the same guarantee of fault tolerance for TensorFlow clusters that we have for Apache Ignite clusters. I will provide the link with detailed information of this feature in the last slide. And as I mentioned, TensorFlow, Apache Spark, other, maybe not limitations, but at least from my point of view, problems. As I mentioned, Apache Spark have a big overhead if we want to build labeled data sets that based on labeled vectors. In that case, we should move our data at least twice from Spark to Parquet and from Parquet back to Spark. And also, Spark uses sparse matrix, which is not distributed at all in lots of algorithms. And last but not least, it uses RDDs inside his data set, so it could be complicated for data scientists, for example, debugging distributed model training process. But it's not always a simple task even for Java developers and for Spark developers too. So, actually, I'm not saying that all that you need is Apache Ignite. We're able to work with lots of other instruments in lots of other scenarios where we can use machine learning. And the first scenarios, yes, it's actually more just about Apache Ignite. We support a case where you could use Apache Ignite as in-memory database with built-in machine learning engine. And you can see here the example of using pre-trained model in your SQL query. Although we have a possibility to import pre-trained models from other libraries like Apache Spark and XGBoost. And if after this importing we provide for these models, we provide the same features that we have for our own models. It means that you will be able to apply online learning API for this, or Ensemble training API for this, or include this model to pipelines. Also, you can use Apache Ignite as a distributed platform for model inference. In that case, we provide inference gateway that have some request and response queue, and for that we have our model service, where you're able to deploy models for further inference. You can set how many instances of model do you need, and where this model should be located on what nodes. It could be useful when you will build applications that rely on streaming analytics, where you want to apply your models during some streaming input. And the last cool feature that I have, this one is really cool, and this is the really new feature. We offer a special Python plugin API that adds support of Python API for all machine learning features for Apache Ignite and for GridGain. This plugin already available via pip, but unfortunately we don't have any public release yet. which will work with this plugin. But you're able to download all sources and build it by your own and try this feature right now. And also, I want to show small draft of possible application architecture. Yes, it could be your application. For example, you're able to store your data in Apache Spark and maybe perform some model training using Apache Spark. And also you're able to load your pre-trained model in Apache Ignite and use this as distributed platform for inference. Also you're able to use, for instance, Apache Kafka for building streaming analytical platform, uses Apache Ignite and apply pre-trained machine learning model and deep learning models that trained in TensorFlow for all your new data that you receive from Kafka. And let me repeat. Let me show conclusion that I want to present today, that Apache Ignite is ready for building the distributed systems that use in machine learning and deep learning. And although if you already have some system that performs some part of this chain, for instance, if you already have if you already store your data in Hadoop and in Spark, or you already have your analytical or your streaming platform, or you're using TensorFlow for perform deep learning training and inference, you're able to use Apache Ignite with them. So, and using Apache Ignite with this all external tools, you will receive all extra all extra abilities, all benefits that we provide that missing in Spark, for instance. And in Apache Ignite for machine learning, we have really good tutorial, and you will about machine learning with Apache Ignite, and this is the link for this tutorial. And as I mentioned, this is the links for all other features that I mentioned today. The first one is linked to Apache Ignite itself, basically. The second one is the link for Medium paper about TensorFlow and Apache Ignite integration. And the last one is a link to our GridGain Python ML plugin that will provide Python API for all our machine learning and deep learning features. And that's all that I want to say. Thank you for listening. If you have any question, I will be glad to answer. Yes? Yes. Actually, we have two possibilities. If we use Apache Ignite only as data source, in that case, all that you have is just a distributed data set that located somewhere on other machines. And in that case, you just receive a simple and useful API for that native for TensorFlow for working with Apache Ignite. But if you decide to use our distributed training feature, in that case, yes. As I already mentioned about it, on each node where you have your data, because basically our data stored in partition-based data cache, which deployed all over the cluster. On each node where we have a portion of data, we will deploy TensorFlow instance. We collect all these instances into one cluster. we create a distributed computation graph, we bake it, and after that we will read all data from cluster locally, so no network moving for data. We achieve the same data collocation principle that we have inside Apache Ignite cluster for TensorFlow, and we perform training only on data where it's located. But actually, it's possible to set specific location to TensorFlow cluster. For instance, if you know that you have that your cluster have heterogeneous structure, and you know that you have specific machines with additional computation devices like video card, for instance, from NVIDIA. In that case, you will able to deploy cluster only on this node and aggregate data from the whole cluster. But we recommend using in data collocation way and reduce costs, time costs for ETL. In some cases, it should be more efficient than just collect all data in one big computer. Yes?
I was a bit confused about sort of the terminology at the beginning, because I misunderstood what a trainer is if it's doing pre-processing.
No. Actually, let me... This one, for instance, yes? Actually, trainer train the model, and inside our engine, data preprocessing, it's still some kind of model. So we have trainer for preprocessors because all our preprocessing are distributed. So we need to collect information about the whole data set somehow and perform our normalization for instance, because we don't need, it's scale data only on one machine. So on one machine we will have one scale, on other we have other scale, and when we try to aggregate intermediate result of calculation, we will reduce our computation cost. It means that we need data preprocessing across all data. So it's so the trainer, it's just some kind of producer that produce some model. And if we speak about machine model training itself, yes, this trainer train models. If we speak about data preprocessing, this trainer train preprocessor. Yeah. And inside our engine, they have mostly the same API. So. Any other questions? Yes?
Are there any ways to monitor if there's more data being moved around in terms of like what evolved the data distribution we've got in different metadata running on nodes?
Excuse me, I don't hear you.
Is there a way to monitor when you're training your models, when you're running, how much data is being moved around, whether it's on purpose or by accident, in terms of the intermediate steps?
It's possible when we... Let me show... Oh. Here. It's possible... Unfortunately, we don't have a monitoring tool yet, but yes, it's possible because we have our learning environment where we can set our logging level. So we can add additional logging here and monitor how many data we use. So if there are no other questions, I think that's all from my side. Thank you for your attention.